Hi everybody. Today let's figure out how to name these compounds, shall we? Chapter 7. For today's lesson, we'll take a quick review of the periodic table parts, or the blocks. We'll review what a formula tells us about a compound. We'll look at the law of definite proportions. We'll think about the polyatomic ions and other compounds that you'll need to memorize. It's like the ABCs. And then we'll look at naming the ions, the metal and nonmetal ions that we will be using to make compounds. First, let's start with a quick review of the periodic table. Now, you know that metals are found to the left of the stair step, and the stair step is up here. It goes down, 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 right about there on the periodic table. And so the metals are found on the left side. They have a luster, that means they shine, they conduct electricity. They tend to lose electrons. They're becoming cations, have a positive charge. Remember about calcium is right here. Calcium becomes a cation. And this includes also the transition metals, which are this yellow section in the middle here, and the intertransition metals, which are found down below. Now the nonmetals are found to the right-hand side, so they're in green up here. So this section right up here, and blue, I guess. All right, so those are the nonmetals. They typically are not shiny. They're bad conductors of electricity and heat. They gain electrons or stay neutral in some cases, and then share, like carbon, for example. But if they gain electrons, they become negatively charged. They're found to the right of the metal-nonmetal stair step. Now the metalloids are kind of in the middle. They're sort of like metals and sort of not like metals. And they're right along the stair step. They're in orange up here, pink, I guess that is. Oops. So pink metalloids, they are sometimes called semiconductors. And then the other thing that we need to review is ions. All right, so ions are charged particles. So they're single atoms, like calcium with a +2, or sodium with a +1, or chloride with a -1. Or groups of atoms, and we've just seen this a little bit, things like nitrate, NO3, -1, or SO4, -2, groups of atoms which have a charge. And there are two types of ions. They are cations and anions. And remember, we spell cations with a plus, Ca+ions, and that reminds us. So if you look at the periodic table up here, here's calcium. It becomes a cation. It gets a plus charge. So that's our little way to remember this. Anions are the ones that get the other kind of charge, the negative charge. Let's take a look at two compounds that are typical of ones that we've seen before. CF4 and MgCl2. So the first question that we should try to refresh our memory on is, which of the compounds is molecular and which is ionic? So CF4, if you look at the periodic table, here's carbon right up here, and there's fluorine right there. So they're both from the right side of the periodic table, so this one is molecular. Mg is from the left-hand side of the periodic table. I'm circling it there, Mg, and Cl is from the right side of the stair step. And so that means that this is going to end up being an ionic compound. Mg will have a plus charge, plus something or other, and Cl will have a negative something or other charge. What kind of information could you discern from the formulas? Well, what does CF4 mean? It means there's one carbon atom and there are 4 fluorine atoms. So if you were asked the question, how many atoms are in CF4, you'd say that there are 5. For MgCl2, there's 1 magnesium ion and there are 2 chloride ions. So there are 3 grand total here. Today's first new thing for you is called the law of definite proportions. Now it's new in that it has this fancy name, the law of definite proportions, but it's something that you probably already have intuited or figured out on your own. The definition of the law of definite proportions is, in a particular compound, elements are always combined in the same proportions. That is to say, H2O, water, is always, always, always H2O. You don't hear H3O or H5O or H6O7. It's always H2O. It's a ratio of 2 hydrogens to 1 oxygen. Definite proportions. Get it? In CCl4, carbon tetrachloride, we have 1 carbon and 4 chlorine atoms. Now this one down here, this is where we're heading pretty soon. It's a complicated compound. It's NH4,2SO4. NH4,2, what does that mean? It means that we have an N with 4 H's attached to it, but the 2 means that we have 2 of these. So really we have 2 of everything that's in parentheses. We have 2 N's and 2 sets of 4 H's. So we have 8 H's. And over here on the right side, SO4, that means we have 1 sulfur and 4 oxygens. So we could say we have 2 N's, 8 H's, 1 S, and 4 O's, but often we're going to say this compound, NH4,2SO4, has 2 ammoniums. Ammonium is NH4, and 1 sulfate. 2 NH4s and 1 SO4. These things are called polyatomic ions. Let's try 3 practice problems. If we had 100 water molecules, how many hydrogens and how many oxygens would we have? Well, if we had 100 water molecules, we would have 200 hydrogens, because each H2O has 2 H's. So if we had 100 H2Os, we'd have 200 H's and 100 oxygen atoms. What about the middle one? What if we had 1,000,000 molecules of CCl4? We would have 1,000,000 carbons and 4,000,000 chlorine atoms. Let's look at the bottom one. If we had 400 NH4,2SO4s, how many ammonium ions would we have? Well, 400 of these up here. Well, in each one of them there are 2 NH4s. So if we had 400 of the molecules, we would have twice as many NH4s. We would have 800. So 800 ammonium ions, and we would have 400 sulfate ions. SO4 is a sulfate ion. The law of definite proportions. In this unit, we'll be working with some things called polyatomic ions. Polyatomic ions are groups of atoms with an overall ionic charge, and they behave like ordinary ions. They don't normally separate. So let's take a look at the word polyatomic. Poly means many, and atomic means atoms. So many atoms, but they're still an ion. So some of these polyatomic ions are things that you've probably heard of before, at least some of them. Nitrate, nitrite, hydroxide, cyanide, chlorate, sulfate, sulfite, carbonate, chromate, dichromate, phosphate, and there's more here. Let's take a look at nitrate. I have put a model of nitrate over here on the right side. It's NO3, 1 N and 3 O's, and it has a negative charge. Nitrate. Its formula is NO3 negative 1. Down below is NO2, and you can just barely see a negative charge on this one as well. So this is called nitrite. Nitrite. Nitrate was the first one. Okay, and then the last one down here, its formula is SO4, and it has a negative 1 and a negative 1, negative 2 charge. So its formula is SO4 negative 2, and it's called sulfate, and that is found right here. I will be giving you 2 pieces of paper that look like these right here. I copied and pasted these into the PowerPoint. So the formulas and the names of some compounds and polyatomic ions that any aspiring chemist knows. So the top one up here is SO4 negative 2. We just talked about that. That's called sulfate. So the name of this one is found right here. And notice that sulfate, by the way, can be spelled with an F or with a PH. NO3 negative 1, we just looked at that one. That was called nitrate. And that's right here. And I will have you make flashcards from this, and then we'll spend a whole lot of time in class becoming familiar with all of these polyatomic ions and other compounds. These are the polyatomic ions here. On the same sheet of paper, I have also given you some other things to memorize, and we'll talk about those shortly. Let's talk about some ions that sometimes give us trouble. The transition elements. The transition elements are those found here. It turns out that many transition elements have varying ionic charges. So we will see Fe with a +2 and Fe with a +3, copper with a +1, copper with a +2. The atom has lost 1 electron or 2 electrons. We'll see chromium with a +2 or a +3, lead with a +2 or a +4, and mercury with a +2 or actually a +1, because there are 2 Hg atoms. There are 2 atoms in the transition area, a dependable charge, and those are zinc, which almost always has a +2, and silver, which almost always has a +1 charge. Let's talk about naming these. What do you call them? Well, Fe with a +2 is called iron 2. Iron, Fe, with a +3 charge is called iron 3. This one is called zinc ion. You don't have to say zinc 2 because everybody knows it's a +2. And the other one is silver ion. and silver always gets a +2 if it has a charge. The transition elements require some special naming techniques, but the representative elements are usually actually easier. And the representative elements are those that don't include the transitions. So representative elements usually have definite charges. Na plus is just called sodium ion. It always gets a +1 charge. The anions, like Cl with a negative, end with IDE. So Cl negative is called chloride. So what have we learned today? We took a quick review of the periodic table blocks. We reviewed what a formula tells us. We've looked at the law of definite proportions, and we've started thinking about polyatomic ions and what that means, and we've started memorizing them, whether we know it or not. And we've even started looking at naming metal and non-metal ions. All right. So thank you for watching, and if you have any troubles, make sure you stop in for help.